Yeah,
Hello, new students. We can't see you, but we're glad you're here.
yeah. Okay, well, I think since everyone's just jumping in from the main session and Jessica made it, so we'll assume that people made it, and I think we'll just get going. Hello, everyone. My name is Andrew Duvall. I'm a professor in mechanical engineering and joined by 5 students that are some of the leaders in our student clubs, and Professor Melinda Keller, who's going to be helping us out with the questions. Melinda and I have both been involved in the student clubs for the time that we've been at Cal Poly, and we're both Cal Poly grads also. So yeah, a lot of people ask Cal Poly how we got our reputation. You know, we're gaining this national reputation, and a lot of it, I think, is from what you're about to see. Our student clubs go out and compete and present nationally, internationally even, and you know, they've really built up a reputation for doing excellent work and interesting work. And I think you'll see just a smattering of that today. There are, I don't even know the current number, it's triple figures of the clubs that our students have the options to join. These are more Emmy focused ones that you'll see today, but they all have students from other majors involved. And there's, you know, College of Engineering, like Engineers Without Borders, and you've probably may have had a chance to see some of those in other sessions. And then, yeah, just lots and lots of opportunities. So I am going to hand it off to our first student, and let's get that going. If I can see it. Except we started at the end. Okay, we're going to hand it off to Weston.
Great, thanks, Dr. Duvall. Hi, everyone. My name is Weston. I'm a 4th-year student here at Cal Poly. I'm currently pursuing my bachelor's in mechanical engineering with a concentration in mechatronics, and I'm in the blended program, so also pursuing my master's as well. So today I'll be talking about the American Society of Mechanical Engineers chapter here at Cal Poly, better known as ASME. So we can kick it off the next slide.
Yeah, we're working on it.
So basically, our club is focused on connecting students to industry. So as Dr. Duvall mentioned, we have a lot of clubs who are very focused on competitions. So like we kind of picture a Venn diagram of competition clubs, professional organizations, and kind of social clubs. A lot of students cross over in those different realms. ASME is focused on more the professional aspect, but as you'll see in a few other slides here, we also compete in some student competitions as well, and also have social activities too. So bring it to the next slide. So a big thing that we do every year are industry tours. So my favorite event and what got me involved with ASME during my freshman year was the Hoover Dam trip. So during winter quarter, spring quarter kind of differs each year. We do a 3-day trip, Friday, Saturday, Sunday to the Hoover Dam. So on Friday, we tour some sort of company, either in the LA area or the Las Vegas area. This past year, we toured JPL, NASA's Jet Propulsion Laboratory in Pasadena, California. You can see the Curiosity rover model in the bottom left corner from that tour. Then Saturday, we spend the day in Vegas, which is a lot of fun. And then Sunday, we go to the Hoover Dam. Last year, we had a professor named Dr. Thorncroft. You'll see him later. He won the trip with us last year. That was a lot of fun. We also tour a lot of other companies throughout the year. Last year, we did Tesla. We've also toured Lawrence Livermore National Lab, and quite a few others, both local tours and ones in the Bay Area and the LA area. So you can do the next slide now. We also host company info sessions on campus. We usually have most of these around our career fair, which at Cal Poly, we're very lucky to have a career fair in fall, winter, and spring quarters. We have 3 every year, and a bunch of huge companies, a bunch of small companies, a lot of opportunities there. So these 3 are kind of smaller to medium-sized companies. The far left, you can see there's aluminum foam, which has all sorts of applications. We're kind of playing around with it that this company brought. In the middle is Keysight, which they make a lot of electronics equipment, semiconductors, that sort of stuff. And a lot of excited engineers are picking away at their equipment that they brought in the middle. And then the far right, that's a startup in San Luis Obispo. So they don't make the VR headset, but they make the kind of the accessory that the person standing on. It's that pad that lets you kind of walk around. And if you're in a video game, you can kind of like have more immersion there. So we've also had info sessions with Google, with Tesla, with like all sorts of companies throughout the year. So we can kick off the next slide. So we also have competitions as well. So the main one we're involved with is the ASME Student Design Competition. So you can see a little trophy on the top left corner and the bottom. It's an example of one of the robots that a past team has made. This year we're planning on competing in Georgia. We had a paper stacking robot that was basically going to create a tower automatically. And the team was moving on to CDR. Unfortunately, that competition is canceled, but we're really excited with the progress they've made so far this year up to that point. In the top right, that was for my freshman year. That was the walk on water competition at Sacramento State, where we competed against ASME chapters from UCLA, UC Santa Barbara, Davis, Sac State, Chico State. And the third from the left, the one that's standing vertically, that was Cal Poly's. We got second place. We won going the first way across the swimming pool, then coming back. It took us forever to turn around. So you can see our pilot. She's standing right next to it there. So we can go on the next slide. And lastly, we have student leadership opportunities for students. So at the top left, that's just us boothing for, I think it was actually for Open House Club Rush. So, and then the bottom left, that was the Engineering Perspectives and Impact Conference team from a couple years back. That was the first year we actually did it. That was basically like a TEDx style conference where we had 4 to 6 speakers from different companies through academia, to some startups and larger companies as well, that gave like talks on different projects and research projects they're currently working on. So that was a really fun conference to plan, get people, work out all the logistics on that. On the top right, that was a conference we had a couple years back where we had students from our chapter. We hosted it at Cal Poly SLO, and we had students from UC Davis, from UC Santa Barbara, UC Riverside come in, and other schools as well. To basically, we shared what we do with our club, what other clubs do, because like from ASME section to section, it varies a lot. So we kind of learn from each other and try to kind of steal ideas and let other groups steal from us as well. So really enjoy those opportunities because it's kind of cool meeting students from other schools. So we can go on the next slide. Yeah, we're going to open up to questions. I know Dr. Keller will kind of moderate those if you want to enter those in the chat. But while you type those in, just want to also plug your email if you want to. That's our Cal Poly, ASME Cal Poly, slow@gmail.com if you want to take a picture of that. And also, I looked up to see if there are any ASME high school scholarships right now. Unfortunately, the deadline is passed for all those, but you can apply for the ASHRAE Student Scholarship, which is the American Society of Heating, Refrigeration, Air Conditioning Engineering. I think the deadline's in early May, so if you want to get $3,000 and you're a high school senior studying mechanical engineering in the fall, highly recommend you apply for that. It's a good way to get some money before school starts. So if you have any other questions, feel free to enter that in. Just want to also end on, like, it's kind of weird, like, doing this presentation now during my 4th year, because I remember when I was a senior in high school, I went to the ME open house, and it was really great getting to meet the different professors and students and kind of see the different clubs, especially like Cal Poly Racing, and also like all the different labs we have on campus as well. So definitely stay tuned for the rest of the virtual tour, because you'll get to check out some of the labs and the other clubs, and it's a really good opportunity.
Hey, Weston, how many people are in ASME right now?
Right now, so it varies a lot. We have about like 20 like paid dues members that are still students right now, but we have a lot of students because we're open to all mechanical engineering students and just engineering students in general. So we have a lot of different people coming in to our different info sessions and tours as well. What's cool too is since like engineering is such a interdisciplinary field, we often get students from like EE and aerospace and physics and biomedical coming into a lot of info sessions too, because like a lot of times they'll be interested if like Google's coming to talk. And so it's also, even though it's a very mechanical engineering focused club, it's a great way to meet like other students as well.
So we had a question early on that was, what is the largest engineering club at Cal Poly? And I thought it was probably the Society of Women Engineers. What do you think?
I'd agree. I would say definitely SWE has like probably the largest kind of presence when it comes to like pure members and active people coming to their meetings. They do a lot of really cool things on campus.
Does
Like
anybody else presenting want to unmute and give
Uh,
us an idea how big that
and
is?
EWB is pretty big too. Yeah,
Bigger than
Engineers
SWE?
Without Borders. I don't know if it's bigger.
Engineers Without Borders is pretty big. I believe the active membership of SWE is around 300. I don't know
You
for
do
sure.
not have to be a woman to be a member of the Society of Women Engineers.
You just have to be supportive.
Okay. Let's see.
If more questions come up on the current speaker, past speaker, or just things you were wondering, go ahead and type them in the Q&A section, and either I'll type you a response or we'll get to that at the end.
Yeah, so now we're going to show you a pretty new club that it's just a few years old and getting going. And Jessica is going to talk about our wind power.
From the end.
And yeah, I keeps bringing them up to the end. I don't know why.
All good. All right. Hi, everyone. I'm Jess. I'm a part of Cal Poly Wind Power. We started this club last year, and so I'm going to give you a little overview of what it's about. If you click on it real quick. Basically, the long and short of it is that we do everything to do with wind energy, especially on the engineering side of things. So what we've been focused on this last year has been designing and building small-scale wind turbines. You can kind of see the tiny one in that picture. They're all about 2 foot in diameter. We do have one that's 4 feet, but generally we're working with small wind turbines because they're something we can actually build and use. So next slide, please. Yeah, so we do lots of hands-on prototyping. We build everything from scratch. So we've been using all the machinery in the shops, composite layups, everything like that. Everything that we've designed, we've built ourselves. So I think that's something great. You hear again and again about Cal Poly is having that hands-on learning. Ours is just applied to wind energy. And another thing we do is testing. I think the next slide, maybe, yeah. So we do a lot of testing. We've worked within the electrical engineering labs to work on our motors or generators. We do a lot of wind data testing. We're actually working at a local middle school to put in a wind turbine. So you'll see there's to the bottom right, it's a little anemometer that we've been using to collect data at the site so we can size our turbine appropriately. So yeah, we do lots of testing. We'll be working in the wind tunnel as well, something we're hoping to do this quarter, but unfortunately we don't have access to labs anymore. So we'll be definitely, if you do come to Cal Poly and you join our club, we'll be doing tons of that over the fall. And so next slide, please. Yeah, so our 2 current projects, we've got a backpack turbine, which I had no good pictures of, I'm so sorry. But it's a lightweight portable turbine that is used to charge like a phone battery or some sort of like light, something you could take camping. So that's one project we've been working on this year. And then another one has been the school turbine, like I just mentioned. It'll be going into this local middle school. It's called Laguna Middle School. And it'll be used as an educational piece. We've actually learned a lot. We've been working in collaboration with a nonprofit that runs the school garden at this place. So it's been really cool to work with real people from the real world and design a project that'll actually be impactful to these kids' education. So next slide, please. We also work at the Cal Poly Wind Research Center. This was actually established a number of years back by 2 Cal Poly professors. They're actually within the mechanical engineering department. And they've been doing some research that has to do with vibrations and sensing for small wind turbines. And so we've gone out there a few times to help them with their maintenance. It's 75 feet tall. It's really cool. So it's a great opportunity to really actually work on a research project. The next slide, please. Yeah, so the last thing that we've been doing is we actually just got selected for a national competition. It's put on by the Department of Energy and the National Renewable Energy Labs. It's going to be a whole year-long interdisciplinary competition. There is one aspect that's focused on more of the project development of a wind farm. The other aspect, which is probably more interesting to you as mechanical engineers, is designing and building a small wind turbine, such as the ones we've really been designing so far this last year. We're only one, they select 13 teams in the whole nation, so we're really lucky to be representing Cal Poly, and definitely we've been working with all sorts of majors with this and have lots of work to do in a great way. So if you're interested in wind energy, definitely check it out. This will be most of our focus next year. So yeah, if you have any questions, take a picture of that and email Cal Poly Wind Power. But yeah, thank you.
We've got one question from Nick here who says
Okay.
that they're interested in finite element analysis, but their junior college has very limited access to that type of software. Does the Wind Power Club have access to this type of software to improve your turbines?
Yeah, I think the whole department does. All mechanical engineering students actually took a class with Abacus. I believe we have access to ANSYS, maybe some other CFD programs as well. But yeah, we've
Altair,
got tons of
HyperWorks,
software.
ComSol, yeah.
Yeah.
And we also have a summer undergraduate research partnership that allows people to go deeper into that kind of thing, especially with the wind subjects. A lot of those going on.
Okay, well, yeah, keep the questions coming. We'll also have time at the end for general questions, or if you want to go back to one of the presenters, that'd be great. So next up we have Kai, and Kai's going to talk about a very interesting club that I don't know that there's many other universities that have this. So let's bring up that share. Whoa, we're getting there. How's that working?
Perfect.
Okay.
All right. Hi, everyone. My name's Kai Kizan. I am a third-year mechanical engineer here at Cal Poly. I'm also a current Disneyland cast member, and I am representing the Cal Poly Amusement Park Engineers and Designers, often referred to as CAPED. We are your one-stop shop for everything to do with the themed entertainment industry. So if you can go ahead and hit that next slide for me. We are a multidisciplinary club that strives to provide connections to and appreciate the themed entertainment industry. Now that's kind of, our fancy frou-frou language for saying we love amusement parks and everything to do with them. And it's our job to make sure that you have the opportunities throughout your college career to pursue a career in that industry. We do that by focusing on 4 major things: learning about the industry, experiencing the different facets of the industry, and of course, appreciating everything we get to love, and then designing as well. Go ahead and hit the next slide. So this is kind of what most people think the themed entertainment industry is, right? We've got Disneyland and we've got Universal, and maybe even Six Flags and SeaWorld and some of those folks as well. But if you hit the next slide, this is a small sampling of all the different companies that work with the themed entertainment industry, whether it's companies like Vekoma and Intamin that manufacture roller coasters, or Oceaneering and Thinkwell that work to create dark ride experiences like those at Disneyland, Indiana Jones, and the new Rise of the Resistance. Tate and others work on both fixed attractions within different themed entertainment locations, like the shows at the Hyperion Theater at Disneyland, as well as traveling masterpieces like Taylor Swift's concerts and all those crazy things. So there's lots of different ways to be involved with themed entertainment outside of just working directly for Disney and Universal. Go ahead and hit that next slide for me. So what is it that we at CAPED do as a club? Well, we have a couple of different facets. We have our club projects and we have our club competitions. So first I'm going to talk a little bit about the competitions that we get involved in, because there are quite a few opportunities within the themed entertainment industry. One of the first big ones is called Imaginations. It is for juniors and seniors to compete in a competition organized by Walt Disney Imagineering. Every year this competition changes a little bit. In previous years they've had us design a University Union type experience or even a small themed land. So we organize students to get involved with that and help them find teams. Similarly, there is a Cornell themed entertainment design competition hosted by Whitewater, an attraction company. That is another opportunity for our students to get some design experience and go through a structured design competition. And then new this year, because of our current situation, we are running our very first CAPED virtual design competition. So students are actively competing right now on a series of design challenges to build a themed land. They're specking out a whole bunch of interesting details about everything from crowd flow to attraction design. So we're excited to be challenging them in new ways. If you go and hit that next slide for me. We also have a various number of club projects that are in the works. One of the first ones, and one of my personal favorites, is referred to as the Iron Man Initiative. is a project to build a full-sized Iron Man suit wearable by a standard human. Go ahead and keep on clicking. I didn't know this had
Yeah.
fun little things in it. So it's being built in a couple of different ways. There are some 3D modeled and printed parts that are printed in our machine shops on campus, as well as we're using a method sometimes referred to as pepakura, where you cut paper, form it together, and then plaster and fiberglass it. So that's some very interesting artistic talents that our engineers are developing. And then, of course, we also feature a lot of artists in our club, and they're working very hard on the final design. A little hint, we might be retooling a bit to have our Iron Mustang out here. Go ahead and hit the next slide. And then our second project that's also working right now, but is kind of on hold as well, as our GoPro Dark Ride. So there is a team of about 20 students that are working on a scaled dark ride project. So if you've ever seen anything that looks like a model of what some of our dark rides look like, this is what they're doing. They're building a scale model to a GoPro of a dark ride. So they've created and designed their very own attraction based on a lovable little alien. And they are now working on getting ready to manufacture that in the fall come that. There are engineers who worked on a conveyance system for the GoPro, as well as designers who did all the storyboarding and artistic work on that. I believe there's 2 more bullet points, and then we can head on to the next slide. One more, there we go. Awesome, so there are awesome opportunities with us here at CAPED, and this QR code right here, if you scan it, that'll put you on our interest list so that we can reach out to you. If you have any questions that don't get answered here, or you'd like to learn just a little bit more about our club or maybe some specific things about it, you can reach out to our email right there, slowcaped@gmail.com. Myself or one of my fellow officers would be happy to give you a hand. So we can go ahead and leave that QR code up. That's about all I have. If you have any questions, feel free to reach out now.
Hey, Kai, where does CAPED travel to each year?
So CAPED has a lot of really cool travel opportunities. We actually made it to all of our travel opportunities this year before everything kind of started to slow down. In the fall, we traveled to IAAPA, which is an industry conference for the International Association of Amusement Parks and Attractions. It is a big industry conference. Think almost like Comic-Con, but for all the people involved with the themed entertainment division. So we send out a group of students over to Orlando, Florida to experience that. We also have trips to the 2 different meetings of ASTM. ASTM is a standards body that writes standards for everything from amusement attractions to paper cups. And their ASTM F24 division works on amusement attractions devices. We have a group of students who also work with them very closely to develop new standards. Myself and others are working right now on a standard related to zipline accelerations, and that has been a very unique challenge and something that we have gotten to learn a lot of different things that just don't really come up in other areas of engineering, and also get really involved with real life engineers doing actual work and kind of learn some of that lingo and all that.
I have a quick question. If you're doing like zipline research, does that mean you have to ride ziplines?
Oh yes, absolutely.
Cool. I don't see any other questions coming in.
Okay. So now if there's any parents lingering out there, or alums from Cal Poly, this is probably what you think of when you think of the clubs that were here when you were a student. This is the kind of the classic Cal Poly club experience that a lot of people think about, and we're going to hand this off to Raymond.
Thanks, Dr. Duvall. Well, hi everyone. My name is Raymond. I'm the president of Cal Poly Racing this year. I'm a 5th year grad student at Cal Poly. So I did my undergrad kind of in Weston's shoes, by a year ahead, since he'll be doing the 4+1 program. But yeah, Cal Poly Racing is the collegiate SAE chapter, the Society of Automotive Engineers chapter at Cal Poly. What we do basically, long story short, we build 3 cars every year, and we test them, and then we compete at the end of the year. So this picture in this first slide is from our unveiling event last year. So usually during spring quarter, we would have a big unveiling event to show off our cars to friends and family, to sponsors who want to come, to the department, to the whole school, basically. So if you go to the next slide.
I have to remember it.
Yeah, so for Cal Poly Racing, we built 3 cars, and we go through pretty much a 3-step process of designing, building, testing, and then I guess you include a 4th one of competing. But we start designing our cars even before the school year starts in the summer. So on the picture on the left, someone's working on what looks like a suspension mount. And then in the second picture and the third picture on the right, people are starting to work and build the cars. So we kind of follow our quarter system, which works out pretty well. During the fall, we design our cars. During the winter, we build them. And during the spring, we test them. So if you go to the next slide. Yeah, so during the spring quarter, we test our cars pretty much for almost 10 weeks straight, every single weekend, and sometimes even during weekdays. For Formula SAE, sometimes we test on campus on an empty parking lot, or we'll go to the Santa Maria airport or even Buttonwillow to get some testing done. And while we're testing, we're not just driving around the car just for fun. We pretty much drive it as hard as we can. If we break something, it does kind of suck because we have to fix it, but it does show that you know, our design was maybe a little lacking. We need to fix it before we go to competition. Since we don't want to have a break at competition, it's better to find all our mistakes or anything during our testing season. Baja SAE will go out sometimes around campus as well, kind of in the agriculture fields when it's empty. And they also go on camping trips out to Pozo, which is just like kind of like a desert mountainy area to get some testing done, since testing on flat ground doesn't really help them, like Formula SAE. And then lastly, the teams will compete. Usually, Baja usually competes in 2 competitions every year, and then Formula usually competes in just 1 at the end of the year. But due to coronavirus pandemic this year, the competitions have been canceled. And in lieu of that, SAE is holding just a virtual competition in which we'll still do our static events, which include like design judging, where we get to talk to judges and tell them about our car, why we designed it the way we did. There'll be like a cost presentation of how much our car costed and what strategies we made to minimize the cost of the car, and then a business presentation, basically where we pretty much try to sell the car to whoever would want to buy it. If you go to the next slide. Yeah, so for Formula SAE specifically, pictured here is our car from last year, so our 2019 car competing. The competition that we go to used to be in Nebraska. So right after school ends in June, we would drive out there, take 3 days to drive out there and compete for 4 days. But Formula SAE, one thing that's very unique about Cal Poly's SAE team is that we have a combustion and an electric car. Most teams usually only have 1 or have 2 separate teams per school. For us, we are 1 team that designs 2 cars. So this is our combustion car competing. And I've got the next slide. This is our Baja 2019 car from last year. I believe this was taken at their competition right before the event started, since Baja has to drive through sand, dirt, water pits, so the car gets wet, more dirt gets on it. After the competition, I think they added about like 80 pounds of just dirt and mud on the car. But Baja, they built an off-road vehicle. Their events are a lot more, definitely a lot more fun to watch. They climb over rocks, climb hills, and they flip pretty often, more so than, you'll never see a Formula car flip. If you go to the next slide. Yeah, so this club is a really, really good experience. We kind of go through a process that pretty much any engineering company will go through of R&D, designing, eventually pushing production and building, and then testing, and then releasing it to the market or whatever the customer is. And these are just some of the places that some Cal Poly Racing alumni have worked at. It's not exhaustive, but this list has definitely changed. Sometimes people work there as just interns. Some people work there full time. But it's just a really good experience to bolster your Cal Poly engineering experience. And I always say that I would always love people to join Cal Poly Racing, but any of the engineering clubs at Cal Poly are just amazing in what they do. They all give you just, like that extra experience that you need, that really supplements what you're learning in the classroom. But yeah, next slide. Yeah, so I don't have a contact here, but if you have any questions, you can send them here or contact team@calpolyracing.org. And yeah, thanks for listening.
We have one question, and it's kind of general. I'll throw it to Ray,
Sure.
and then the other students can chime in. Can you talk a little bit about how difficult it is to balance your club life versus your courses life?
Yeah, I can start with this. Definitely, it can be pretty difficult, but it's definitely possible. I think for myself, my third and fourth year is when I was really, really involved in the club. I think then I definitely did sacrifice a little bit of my schoolwork to focus on my club work. I'm not saying that you shouldn't neglect doing school, because if you can't really participate in these clubs if you're not a student, or if you're not performing well as a student. I think it's just all about balance, finding what is appropriate for you in terms of commitment to the club, because every club kind of has different level of commitment. You can be kind of like a project manager versus just a subsystem lead versus just someone who wants to practice honing in their skills on designing and manufacturing. So it's really up to you how much you want to get involved and like how much you want to have on your plate.
And you have the 5 most dedicated student club people here to answer this question. And I know of the people here, they also are like in the Cal Poly band or shop techs or other things as well. So let's go. Kira, do you want to answer that question from your perspective?
Yeah, I can answer that as well. I would definitely agree with Raymond. Depending on your involvement in club, you can kind of change around your course level. But something I would really like to emphasize is the courses and clubs really supplement each other really well, kind of like Raymond went into with getting that extra level experience. Another thing, for example, I was really involved in the Human Powered Vehicle Club, which I'll be talking about next, and I did my senior project on it. So that's a really cool crossover. And in doing my senior project, I utilized so much that I learned in my design 328 class that I know Dr. Duvall teaches all the time. I used like my basic statics, dynamics stuff, even from my freshman year that I learned in my drafting skills. And then I was able to increase those skills in a club setting instead of just utilizing skills as far as projects that are given to you in class, kind of further expanding upon what I learned in class and applying it to a real project, which is basically what clubs are all about.
Clubs make the material stick. Kai, do you want to talk about your commitments?
Yeah, sure. I'm also a drum major for our marching band, the Mustang Band here at Cal Poly. We have a great time. Check us out. We have a session tonight at 6 that I'll plug now since it came up. In terms of balancing everything, what I like to remember is you have passions, and it is important that you pursue those passions, because those passions are what make you a unique engineer. Every single engineer that comes out of Cal Poly is going to be taking all the courses that you're taking. However, not every engineer that comes out of Cal Poly is going to have, climbed around in the guts of Space Mountain, or, designed a human power vehicle, or, been the student that figured out what the problem was with the formula car. Your passions are what take you that extra step when it comes to those interviews. And something that Cal Poly is really, really good about is developing human engineers, not just theoretical engineers. So each of these clubs that you're involved with are a portion of who you are as an engineer. So make sure that you consider all that when you're looking at what you want to get involved with.
And Jessica, you looked like you wanted to say something too.
Yeah, I would say something that I've learned is that you get as much out as you put in. So if you only want to be slightly involved, you'll get some learning out of it. But if you put more effort in, you'll probably learn much, much more. So that's just kind of like your commitment level can definitely vary on how much you want to get out of it.
All right, that looks like the only question for now.
We'll let's start Kira up here. And I think we're going.
Awesome. So hi everyone, my name is Kira Schmidt. I'm a 5th year mechanical engineering senior, and I'm here to talk a little bit about the Cal Poly Human Powered Vehicle Club. So we can move on to the next slide. So the Cal Poly Human Powered Vehicle Club is currently the national collegiate record holder. So we went to a competition last year and we broke the national collegiate land speed record at 63 miles an hour. For a little bit of fun trivia, that record had previously been held by University of California, Berkeley for the last 27 years. So that was an awesome experience for us to be able to do. And our vehicle reached a maximum speed of just a little over 66 miles an hour, purely under a human's own power. So next slide. So who are we as a team? So we're a team of about 25 students from all majors and class levels, though we are predominantly comprised of mechanical engineering. You can see here on the left a picture of our team at competition as well as the rider of our vehicle. Next slide. So what do we do? The human-powered vehicle team builds exactly what it sounds like, a human-powered vehicle. That means no electricity, no stored energy, just a vehicle that is powered purely by a person's own strength. What that usually comes out to is some sort of bicycle. You can see a picture of our bicycle on the left at competition. The competition that we get to go to is a super awesome experience. It's called Battle Mountain because it's hosted in Battle Mountain, Nevada, and it's an international competition. So when we go to competition, we're not only competing against other colleges, but we're competing against professionals, amateurs, and we're not only competing against teams from the US, but teams from all over. We got to meet teams from Italy, Japan, Canada, Mexico. It's an international competition, and everybody comes to Battle Mountain for this 1 week in September to push the limits of engineering and human endurance. So next slide. So you can see here some pictures of our vehicle from this year. This is the bicycle that we built this year for the competition that did break the record. You can see there are a couple of elements that differentiate it from what you would normally think of as a bicycle and allow it to reach those high speeds. So we have a recumbent bicycle, which basically means the rider is kind of in a laid back position when they're pedaling the bicycle. And you can see on the left, the chassis on the welding table as we were building the bicycle. In the middle, you can see the back half of what's called a fairing, which is an aerodynamic element that basically breaks the wind for the rider and allows the bicycle to go so much faster than what you would normally see on a bicycle. And then finally on the right, you can see the drivetrain. We have a 2-stage drivetrain and it is front wheel drive as well. So when the rider pedals at about 75 RPM, our front wheel spins at well over 1,000 RPM. So next slide. So what do we do? As a club, each year we design, build, test, and race a human-powered streamliner, and then you can see there is a cutaway view of our bicycle from this year. You can kind of see how everything fits together inside of the fairing. And then next slide. So I know there were some questions earlier about finite element analysis and other software, so this is perfect for this slide. We start out each fall, similar to Cal Poly Racing, with the design process. And all fall is us basically taking a concept from a blank CAD file, zero idea what we're gonna do, to a fully designed vehicle. Something we really value as a club is getting members involved from the ground up. So any new member joining can get involved right away in the design process. We pair new members with older members that are experienced and get everybody involved in different aspects of the vehicle that they are interested in. For example, you can see some CFD use on the aerodynamic fairing. You can see some finite element analysis use on the frame. And then a bunch of other different tools that we utilize that have been made available to us by Cal Poly in order to design the vehicle as best we can. And next slide. So after the design process is over, we go to the building process. This is a really fun part and something very close to my heart as a shop technician in the Cal Poly shops, as well as one of the manufacturing leads from last year. We do a lot of different processes in the club, and we teach all the members how to do everything. You don't have to have any experience before joining, and we'll teach you how to do everything. So you can see in the top right, we do a lot of composites work with carbon fiber, fiberglass for our fairing. You can see we do a lot of metal fabrication, welding, grinding, tube fitting, tube bending. You can see in the middle slides in order to create the chassis of our vehicle, and then a lot of jigging as well. So you can see a couple of different slides. Then right there in the middle is us test fitting. So because our rider is such an integral part of the whole system, every single time we build something, we bring him in for a test fit. He gets to sit down on the bike, see how he feels, and then you can see us doing that in the middle there. So next slide. And then finally, once we're done building it, we get to see how well it actually works and get to test the bike out. So spring quarter and summer quarter for our club is the testing quarter. And that basically means a lot of different things. One of the big parts of our testing is getting our rider out on the road, pedaling the bike, seeing how it feels, pushing it to see how fast as it can go and getting him used to it. In addition, we do a lot of just engineering level testing. For example, Instron testing to validate the finite element analysis that we used earlier in design season to design our bike, as well as other parameters. Another kind of interesting fun part about our club that I really enjoy is I came from being a high school athlete, and that was something that I really wanted, I kind of missed when I went to Cal Poly, was kind of the athleticism. But because we have a human as such an integral part of our vehicle, we're not only engineering the vehicle part, but I got to basically write the training plans for our rider, develop his nutrition plans, and kind of get involved in aspects that you may be passionate about that may not specifically relate to engineering. Our club has a lot of wide varieties of interest there, so that was really fun. And then finally, next slide, the part that we've all been waiting for is the race. So we go to Battle Mountain, Nevada for 8 days, and we race twice a day for 8 days. So it's a crazy week. It's a lot of fun. It's a lot of racing. You can see there the team getting ready at the start line, the team launching the bike, and then the bottom right, the bike going past the finish line. This is an awesome week, a really good culmination of everything that we spent the year working on, and also a really great time to expand your own skills. We get to talk to all the other teams from across the world to see what they designed, what they built, get ideas, and improve that all, take it all together to improve the vehicle for the coming years. So next slide. Finally, beyond just breaking records, what are we interested in as a club? Something, again, like I said before, we really value involvement from all members. We are a little bit of a smaller club as engineering clubs go, but because of that, every single member gets really involved right off the bat and has really big ownership over their part of the vehicle. In addition, we have a lot of industry experience. We have a lot of contacts and sponsors across different industries, and we work with them in order to get our vehicle built, get the resources that we need, and all members are involved in that process. In addition, we welcome members from any major, any class level, any experience level. Anyone is welcome in the club, and we'll teach you what you need to know. And then also on that note, not only teaching our own members of the club, but our club really values improving the entire mechanical engineering's bodies experience. And so we work closely with a lot of other clubs, members from other clubs, not just our clubs, teaching them what we know. We actually taught some of our processes to a couple of different clubs across campus, and learning from them in turn to keep a whole community of learning going. And then finally, continual improvement. We did break the record this year, and that was awesome, but we are of course looking to reach even further and go even faster in future years. So next slide. Now this is a good time to ask any questions while you're kind of formulating those questions and thinking about them. If you want to take a quick picture of this slide, you can find us on our website. You can scroll through our Instagram and Facebook to see what the team has kind of been up to over the years, or you can message us on those, or you can send an email to the email listed on our website to get in contact with us.
We have a question, Kira.
Awesome.
What materials were used to make the shell for the human powered vehicle?
Sweet. So the shell for the human-powered vehicle was made with carbon fiber and fiberglass as the composite materials, and then we utilize honeycomb core and a couple of other Divina cells, Divina mats in various locations.
And what is the frame made of?
The frame is made of 4130 chromoly steel tubing, but it's very thin wall. So it looks like a lot of steel tubing, but the frame itself actually only weighs 22 pounds, so fairly light. Most of the wall thicknesses are 35 thou, so steel tubing, thin wall steel tubing.
Have bikes in different years been made of different things?
Yes, in fact. So I've been involved in the Human Powered Vehicle Club for 3 years on campus. And one of the other years that I was involved, we did a carbon fiber monocoque. So kind of what the Formula car currently does, where the structure and the aerodynamic shell and everything is integrated into one piece. So we've made them out of carbon fiber before and composites. And we are looking to basically, as the club goes on, move more and more of our components to composite, because that is the way of the future, that is the lightest possible. But there are a couple more risks and design trade-offs involved in that. So we're looking to gradually push the club in that direction as well.
And then we've got, our students offered student versions of the software mentioned.
Yes, yeah. So we, for example, use ANSYS to analyze our frame. We are able to get that through the licensing and through being a student. We use STAR for our computational fluid dynamics. I know that was mentioned a little bit earlier. We do CFD on the fairing, and all the students are able to run these programs locally on their computers or run them through the many labs that Cal Poly has offered. We can do our analysis there.
We have 3 more questions as well. How difficult is it to get into these clubs? And I think this was directed at everybody. So I'll just answer. You just show up and you're in.
Yeah, like I mentioned in ours, and I know goes for all of the clubs listed here, no experience necessary. You just join anything that you think is interesting. And kind of on that note, I'd recommend just join a few, you know, feel it out, see what you like. That's what I did. Then I kind of found my home as time went on, but no experience. You just wander into the meeting and somebody will take you under their wing and start giving you all the information you need.
Yeah,
And that being said,
from the professor's standpoint, I generally teach the freshman intro a lot. So if some of you are coming here in the fall, good chance you'll see me in the freshman intro lab in the fall. I tell the students it's great to show up, and as many of our presenters mentioned, get involved in a small way in the manufacturing, helping out. But someone asked a question earlier about the balance. Obviously, you know, the first year, even for transfers, right away, you got to concentrate on the classes, and then you'll build your involvement in the club.
yeah, also on that note, later on, if you want to be a lead or one of these officers, there's definitely application process. So there's lots of things to do, and then it gets tighter and tighter as you move up. Next question is just for Kira. How much does the whole vehicle weigh altogether?
So altogether, probably about 50 pounds. So it's fairly heavy because we have a lot of different components in there. We have 5-point racing harness in order to keep our riders safe. I know there was some mention of the Formula car not rolling over. The human-powered vehicle actually does sometimes roll over, but we rolled over 3 times at 45 miles an hour, but our vehicle was designed so safely that all that happened was the fairing got scratched. So that's a little fun trivia. You can find that video on YouTube if you're curious. So yeah, there's a lot of different components that contribute. So it's not, I would say, a super lightweight vehicle, but because our course is fairly flat, weight, while definitely a factor, is not a huge defining factor of our vehicle.
And then Nick has one more question. Why a combination of carbon fiber and fiberglass? Why not one material? That's kind of detailed.
Yeah, so the reason that we went with fiberglass, we put fiberglass on the outside of our fairing because it's much more sandable than carbon. So once you do the initial layups, even if you think you've got a good finish, you're sanding at least to 1,000 grit, because at the level of speed that we're trying to attain, it's not only the form drag, but also the skin drag that matters. So we basically, once we formulate the shell and put it all together, there's a large sanding process that goes into it. So we sanded all the way up to about 1,000 grit on our fairing. And the reason we put fiberglass on the outside was because carbon, I don't know if anyone here, I know some of the people in clubs, I don't know if any of the panelists have sanded carbon before. It can become a pretty big pain. So we put a fiberglass layer on the outside in order to help with that. But most of the structure of our vehicle does come from the carbon fiber and core composite.
Just point of note, 25 years ago, I was team lead for human powered. So I spent those days sanding as well. So yes, it's a long tradition.
Is that it for questions?
I have one more for Drew, or I could answer it myself, but I hate talking to myself. How many other clubs do we have in College of Engineering that people could get involved with?
Oh, I've lost track. Just to give you one example, I'm an advisor of a brand new club that just started this year that is a musical instrument building club. So these things, it really just, as many clubs as there are student imaginations, and as Kai said, it's students following their passion. Oh, and by the way, Kai, I think President Armstrong is going to want me to send that clip of you saying that, and they're going to publish it, just so you know.
Do with it as you will.
Yeah, but it is, yeah, there is so many, and it really depends what you're looking for. If, like Raymond mentioned, if you're president of SAE, you're running a big organization. A lot of money, a lot of people, a lot of time and parts, and there's also very small ones. Like this instrument building club right now is 3 people, I think. Jessica is a founding member of the Wind Club, and so these things build from small into big sometimes. But yeah, many opportunities. And I would just like to mention that, and I think a lot of these presenters did, they show the companies, from a company's perspective, if you're coming to Cal Poly to hire a student, the learn by doing at Cal Poly is real. And that's what they're looking for, right? And I think Kai mentioned this also. The Tesla, virtually won't talk to you if you're not part of SAE, or I think you could probably convince them that, the HPV experience, human powered vehicle experience, was applicable to their vehicles. But yeah, they don't necessarily want to see the 3.9 grade point average. They want to see that you had a passion for vehicles and that you showed it on a club.
Can you create a club during your freshman year? Yes. In fact, I gave a presentation to Drew's freshman class over 10 years ago, and one of the girls in that club came to me afterward and said, "You worked on roller coasters? I want to start a roller coaster club." And it was a freshman who founded Caped.
Who was that, Melinda?
That is Kelly Stoll. At that time, she was Kelly Rorden. She went on to work for Wet Design, and she designed some of the big fountains you see at the Block of Orange in Universal Studios. She also worked for Jim Henson's puppet design, and now she works somewhere that I've forgotten. But yeah, it's amazing. When are you able to join Cal Poly Racing? Probably not before September. Can they join in for the summer, Weston? Oh, sorry, Ray. That was Ray.
Yeah, no worries. I think you probably have to wait until fall rolls around. But during the fall, us as well as every other club is going to be kind of advertising like crazy during club showcase. During the first few weeks, we're all going to have meetings and all that stuff. But yeah, probably not until the fall.
Yeah, at the ME welcome, the first time that you guys actually meet the ME department and faculty, many of these students will be there with the clubs. And then during WOW Week, there is the club showcase that Raymond mentioned. So the first week, 2 weeks of school, you'll have lots of exposure and lots of opportunities to join in on these clubs.
And I think all the clubs have special, like, getting to know the club training sessions just for the freshmen. So you won't be alone or unwanted. Everybody wants you. It's a really included kind of feeling. Do you know if there are any prostheses related clubs? Yes, I was hoping somebody would ask that. We have several. I don't want to answer the question though, because Kira looks really excited about it.
Oh, I'm not currently a member, but I have some friends that are members of the QL Plus Design Club, Quality of Life Design Club, and they do a lot of work with prostheses and just also a lot of work in general with their whole club's foundation is founded on designing and building objects or products that help people that have various medical conditions live their life easier.
And we also have the Gate Lab. Drew, do you want to talk about the Gate Lab?
Yeah, so there's, and this is more research than club oriented, but yeah, we do have a biomechanics laboratory with some very sophisticated camera equipment and software and lots of data acquisition. And they work with, people with all kinds of different challenges like prosthetics. Yeah, the QL Plus Lab that may be one of the biggest clubs also. I go by there on Tuesday night when they have their meetings, and it's over 100 people.
Yeah. And then, for instance, last summer, I did some research with some students on biomimicry, and we were looking at the fluid motor that's present in some plants. When you touch them, they close. We're trying to get a hand to do that biomimicry stuff. So there are clubs, there are labs, there are research opportunities. We have a lot of prosthetics work going on in the mechanical engineering department.
Anything else? Well, hopefully you were able to get.
There's another one. If we want to see how our courses are working out before committing to a club, is there an issue joining mid-quarter? Oh, I can answer that too, but everybody's just shaking their heads. No, there's no issue. Nobody would have an issue with that. In fact, lots of people jump in and out. Once you have a leadership role, you're probably going to need to step up that commitment. But let's see. It looks like, Weston, you haven't talked in a while. You want to answer that one?
Sure. So I know I've been very involved with Rosefloat these past 4 years, and I started my freshman year, but like I've had a friend, my friend Jared, he's the same year as me, and he started like last year, and he's super involved now. It's like it's never too late to get involved with organizations. You could start doing your senior year and still be a rock star, even if you didn't start during your freshman year. It's never too late, at least for most clubs.
Yeah, one of the things, several of the students you see here are technicians in our student shops, and you'll get certified to work in those shops your first quarter as part of the freshman intro class. And in that class, I always recommend to the students, show up at the shops on the weekends. And you don't have to necessarily even join a club. They always have things they need. Usually you're going to start sanding something. For pretty much any club you join, you'll be sanding something. But yeah, they have lots of small projects that they're happy. A lot of times if you just say, I'm just trying to get some hours in the shop towards my higher certifications, that's a great way to put your toe in the water while you're still really just focusing on getting comfortable in your classes.
All right. I think that's all I'm seeing here.
Okay. Well, you've got the students' contact information. We strategically didn't put Melinda and my contact information because they're much better to talk to than us. But please feel free to reach out. And we hope to see you non-virtually in the fall. Everyone take care.